Thank you. This is Algebra 1, Lesson 6.2, solving multi-step linear inequalities. That's our goal. We're solving multi-step. Last couple days we've been doing one-step inequalities. Today we're beginning on page 340. Example number 1 is using more than one step. We're going to treat them just like an equation. 5 over 6x minus 2 is less than or equal to 18. We're going to treat it as if it says equals 18 instead. You're going to do it the exact same way though. This first step to undo is minus 2. Your order of operations says you have to undo backwards. Add 2 to both sides. If you add it there, you add it here. 18 plus 2 is 20. So you have 5 over 6x. Again, we're treating it as if it says 5 over 6x is equal to 20, and then we'll go back and replace the other part. That says 5 over 6 times x. We know how to cancel out times something. You divide by 5 over 6, which is the same thing as multiplying by its reciprocal. Remember, its reciprocal is a fancy word that just means flip the fraction over. 5 over 6 becomes 6 over 5. And when you multiply the other side by the same 6 over 5, you can cross cancel this to make the numbers a little bit smaller. 5 goes into itself once and into 20 4 times. So when you multiply straight across, 4 times 6 is going to give you the number 24. Now, when you go back from equals back to the inequality sign, you check each of your solution steps. Right here at this solution step, we're adding 2 to both sides. That is not multiplying or dividing by negative numbers. So you leave the inequality, say less than or equal to. On the next step, we multiply by 6 over 5. So we're doing that to both sides. Again, we're multiplying, which is part of what you need to do to reverse it, but it's by positive numbers. These are positive numbers we're multiplying by. So again, you leave the inequality, say less than or equal to, by multiplying each side by 6 over 5. Therefore, the answer is all real numbers, so everything that's bigger than or the same as 24, less than or equal to 24. Again, treat it just like an equation, and then check your solution steps to determine if you have to reverse your symbol or not. Take about 1 minute and solve 5x minus 3 is greater than 12. Okay, for this one, we have 5x minus 3 is greater than 12. Again, you can treat it as if it says 5x minus 3 equals 12, and then we'll just check each of our solution steps to determine if we have to reverse the symbol. We're trying to get it to say x equals by itself. So you want to undo the fact that it says minus 3 first. You work backwards through your order of operations. You add 3. If you do it there, you have to do it here. It'll cancel that side and leave you with 5x on the left equals 12 plus 3 is 15. Then cancel out the fact that it says 5 times x by dividing by 5. You divide that side, you have to do it here, and x is going to be 3. So if we were just an equation, it would be x equals 3. It's not just an equation, no. It is an inequality that says greater than. At this solution step, we're adding 3. That's the operation. We're not multiplying or dividing, and it's definitely not by a negative number, so we do not reverse the symbol. At the next solution step, we are dividing by 5. So we are either multiplying or dividing, but it's by positive number, so we do not reverse the symbol. Therefore, our answer is going to be x is the same symbol greater than, you don't have to reverse it, the 3 that we came up with. X is greater than 3. If you graph x is greater than 3, remember you want to show 2 points. You just want to show 0 and three's relation to that, showing it's a positive number. It says greater than, not greater than, or equal to, so you don't color the bubble in. And this arrow points this direction, so we're going to shade that direction. Another way you can look at that, you can say it's greater than, that has an R in it. That means shade to the right. If it said less than, that has an L in it, shade to the left. Example number 2 is multiplying or dividing by a negative number. That's the difference between example 1 and this one. We're going to have a negative number. So you know if you multiply or divide by a negative number, you're going to have to reverse the sign at one step. 9 minus 3t is less than 7 plus 2t. On top of that, now we have variables on both sides. Again, we're going to treat it just like an equation. We're going to treat it just like an equation. 9 minus 3t equals 7 plus 2t. Again, notice I just subbed in, just for the time being, an equal sign. Now, on their first step, it says to subtract 9. That's fine. Okay. Another way we could have done it is we could have collected all of the variables on one side first. But moving this 9 over. Now, when we do equations, typically we want to bring the smaller variable over to the larger one side. But since at the end with inequalities, we want to make sure the variable's on the left anyways, let's bring everything that's not a variable to the other side, and that's why it has you subtract this positive or plus 9 first. If you subtract it from the left, you're going to do it from the like term on the right. 7 minus 9 we know is negative 2 plus 2t. So we still have equals negative 3t on the other side. Again, I know there's an inequality sign. We'll look at that in a second. Since we brought our constant terms, the ones that don't have variables, to the right-hand side, the next step, we want to bring our other terms, our variable terms, to the left side. It says positive 2t. You undo plus 2t by subtracting it. If you subtract 2t there, you have to make sure to subtract 2t here. Think of what's going on the number line. You start off at negative 3t and you subtract 2 more, which means you go 2 more times to the left. That's why you get negative 5t is equal to negative 2. Again, I know mine says equals and there says less than. Then get rid of negative 5 times t by dividing both sides by negative 5. I'm going to get to show y'all that in a second. If you do it there, do it here. A negative divided by negative is a positive 2 over 5. So we have t equals 2/5. Again, if it was just an equation, it would say t equals 2/5 and it would be done. Check your solution steps to determine if you have to reverse the inequality sign that says less than. At this step, our transformation here was minus 9. That's not multiplying or dividing by a negative number. So your symbol stays as less than. At this step right here, we're subtracting 2t on both sides. Again, not multiplying or dividing by a negative number. Your symbol stays less than. So it's less than, it remains less than. And then finally, on this last transformation you have to do, you have to divide by a negative number. That's the thing that makes you reverse the symbol. Dividing by a negative number is going to change it. And notice it reverses to say greater than on that one. T is greater than 2/5. And since t is greater than 2/5, the solution is all real numbers greater than 2 over 5. Notice it does not say greater than or equal to. Greater than 2 over 5. Okay, take about 1 minute to do this one. Negative 3x plus 1 is less than or equal to 22. Again, this separates your inequality just like it separates your equation. We're trying to get x all by itself. So instead of writing it as a separate problem, we'll just leave the inequality and try to do it all together. Get rid of plus 1 first. Subtract it here. 22 minus 1 is going to be 21. This negative 3x comes down. At that first step, all we did was subtract 1. So we do not reverse the inequality. We leave it just like it is, less than or equal to. On the next one, you have to get rid of negative 3 times x by dividing by negative 3 on both sides. If you divide it there, do it here. Divide by negative 3. 21 divided by a negative 3, a positive divided by negative, is going to be a negative 7. At that step, though, we divided by a negative number. So we have to reverse this symbol less than or equal to and make it say greater than or equal to. So x is greater than or equal to negative 7. Again, it's a simple graph. When you graph it, 0 and negative 7. Greater than or equal to means color the bubble in. It's pointing to the right, so greater than is everything that way. The next one says you pay 45 cents per minute for long distance calls and a monthly fee of $5. How many minutes of long distance can you use to keep within your monthly long distance budget of $20? So it says the amount spent on calls plus the monthly fee must be less than or equal to $20, your monthly budget. We know we can spend 20, but we can't spend $20.01. So it has to be 20 or less than or equal to. So our verbal model's filled in for us already. It's the cost per minute times the number of minutes plus the monthly fee has to be less than or equal to the budget. When we label everything that was given to us, the cost per minute is 0.045, 45 cents per minute. The number of minutes is M. That's the unknown. That's the variable. The monthly fee is $5 and the monthly budget is 20. Notice the fee and the budget are in dollars and the cost per minute, even though it was 45 cents, is given to you in decimals to make it into dollars. So it's all the same units. When you plug everything in where it goes, 45 cents goes into cost per minute. M is the number of minutes plus 5 is the fee is less than or equal to $20. There is your algebraic model. So we know how to solve that. It has one variable, just like the stuff we've been doing. You want to undo the plus 5 by subtracting 5 on both sides. You get 0.045 M is less than or equal to 15 because all we did was subtract 5 on both sides. We didn't do anything to reverse the symbol. Then divide by 0.045, by 0.045, and you get M is less than or equal to 333, and it keeps repeating 0.3 minutes. So you have you have to call for 333 minutes or less. If you go past that, you will go over your monthly fee or your monthly budget of $20. And then this is just showing you when you graph those two equations, that's when you get to a point where you go above at 333, and it's kind of needs to be stretched out a little bit more, but that's the intersecting point there. Let's take a look at your checkpoints. We'll go quick through them. You want to get x by itself. First thing you want to do is subtract 17. Do it there, do it here. 12 minus 17 is negative 5. Negative x, all we did was subtract. We didn't do anything to reverse the symbol. Negative x is greater than or equal to negative 5. Undo the fact that this says negative 1 times x by dividing by negative 1. If you do it there, you have to do it here. A negative divided by negative is a positive 5, but on that step, we did divide by a negative value, so we have to reverse the symbol and make it say less than or equal to. Again, if we graph that, we know 5 is positive, so it's here, or equal to means we're coloring it in, less than means we're going that direction. 3x plus 2 is greater than x minus 8. We're going to do the same thing. We want to get x by itself. You want all of your x's on the left. That says positive x, so subtract x. If you do it there, do it here. 3x minus 1x is going to be 2x. Bring down the rest, plus 2, and we have minus or negative 8. All we did was subtract x right there. We didn't do anything to reverse the symbol. Since you brought 2x to the left, bring plus 2 to the right by subtracting it. If you do it there, do it here. Negative 8 minus 2 is negative 10. So we have 2x. Again, all we did was subtract on that step. So leave greater than. 2x is greater than negative 10. Then get rid of 2 times something by dividing by 2 on both sides. Notice on this last step, we're dividing a negative 10 by something, but we're only dividing by a positive number, 2. So we do not reverse the symbol to get x is greater than negative 5. When we graph that, again, positive number versus a negative, you want 0 there, negative 5 here. It doesn't say or equal to, so you leave the bubble open. Greater than means everything that direction. And then the last one says your school carnival charges $2 for admission plus 50 cents for each game. You go to the carnival with $5.50. Write and solve an inequality that represents the possible number of games you can play. What is the maximum number of games you can play? $2 plus 50 cents per game times X has to be less than or equal to $5.50. There's your inequality. Undo plus 2 by subtracting it. That's $2. It looks like this. So that leaves you with $3.50. You have 50 cents times X has to be less than or equal to that. Divide by 50 cents. Do it here. The number 5 goes into 35 7 times. So we're going to move that decimal over 1, 2 times, 3 times. So 7, you're going to move it over 3 times. And in fact, you don't have to move too many decimals at all, even though it's counting it. You can play 7 games. You divide by a positive 50 cents. X is less than or equal to 7 games. If you play 8 games, or you won't be able to,